Okay, how are we going to figure out what I is for number 1? Okay, well, first thing you got to know is whether it has charges. Okay, NH4 has a charge. You have to know whether it's ionic. Okay, number 1, ammonium you find on the common ions list, and it's NH4 plus. Okay, if I have a plus charge particle, then this must be a negative charge particle. And what is sulfide? Okay, it's sulfur with a 2 negative charge. Okay, so sulfide is sulfur that has gained some extra electrons. So what? No, we haven't finished balancing it yet. How many of these 1 plus particles do I need to balance the 2 plus particle here? So I need 2 of these and 1 of those. So I is 3. 1 particle here, 2 particles here, 1 particle here, right? Wait a minute, I put that in the wrong place. It's 2 of these. Golly, I can't seem to do any of this right today. Let's just do it this way. 2 of those, so it's NH4 2S. Okay? Okay. Number 2. What kind of chemical is this?
That would be
This is acidic. It has a hydrogen on the front. Zach, why don't you go stand at table 4? I'm not saying you're sleeping, but you're not paying attention to this either. Table 4, Zach. Ryan, table 1.
What table?
1. Okay, so this is acidic. Do acids break up in solution? Do acids break up in solution? Yes, they do. I didn't hear your question. Yes, if hydrogen's in the front, it's acidic. In this class, thus far, that's the case, yes. Okay? What charge do the acids, hydrogens, always have?
1 plus.
1 plus. And we have how many of these hydrogen 1 pluses?
3.
Okay, and the back side of this you find on the list of common ions. It's a phosphate ion. It's got a 3 negative charge. How many particles do we have? 4 particles. I equals 4. Number 3, sulfuric acid. We have 3 H pluses and 1 PO4, 3 negative. That's 4 particles.
So you only do that if you don't have to make the equation like it's already made? Okay, that.
Well, okay, you're saying if this formula is already given to you, that's how you do it, yes.
Okay.
All right, sulfuric acid. This IC ending is a little bit tricky sometimes because there are 2 kinds of acid formulas, classifications of acid formulas, that have IC endings. One of them has an IDE anion, and the other one has an ATE anion. We need to know whether this is 8 or ide. Okay? For if it's ide, it would have a hydro prefix. And there's no hydro prefix on this. So it has to be 8. Huh? Well, we'll get to that. Okay? So we need to look then for a polyatomic ion on the common ions list that starts with SULF and ends with ATE. So find the polyatomic ion that starts with SULF and ends with ATE.
Sulfate.
Sulfate. What's its formula?
SO4 3.
2 negative. If it's an acid, what am I going to put on the front? What charge do you put on an H in an acid? Plus. How many of these charges, H pluses, am I going to need? I'm going to need 2 of these. I have to have 2 of these to balance this 2 negative, so the compound itself has a 0 charge. So there I equals 1, 2, 3. Okay? All right. Number 4. Hydro. There's that prefix we're talking about. Hydrosulfuric acid. All right, so we've got this ICE ending that could be an ATE or an IDE. ATE or an IDE. If it's going to be IDE, it has to have a hydro prefix. There is one. So this one is IDE. So we're going to find a sulfide ion. So IDE ions are atoms that have gained electrons. They're negative. All we have to do is find an element with an SULF beginning on the word. Okay? And we'll know what symbol to use for sulfide. Well, that should be sulfur. What kind of charge does a sulfide have? 2 negatives. It has to be a negative charge. If it's an acid, what do we put on the front of it? H plus. How many H pluses do we need?
2.
2.
3.
What is I here?
3.
3. Hello? Sure. Bristol, you need to go by the attendance office when you leave here. Okay? Okay, let's see. Number 5, sulfurous acid. So, Kayla, here's the question you were asking about.
I know you use iodine on the oath, but I was wondering why you put iodine.
Okay. The OUS ending here comes from only one kind of polyatomic ion. A polyatomic ion that has an ITE ending. So to find out what polyatomic ion this fits, or this goes with, you look up on your common ions list, find an ion that starts with SULF and ends with ITE. Sulfite. You need to look this stuff up for yourself and practice. This is that muscle memory we're trying to build here. If you don't do it for yourself, do you learn better from just listening to somebody tell you about it or from doing it for yourself? Neither. Now that's a lie. Yeah, right. I hear what you're saying, okay? And I know what it is you're saying, okay? And it ain't true. You learn better by doing. If you don't get out the test reference and look this stuff up for yourself, you are choosing failure over success. If you want the best chance for success, you need to do as much as you can for yourself. That means get out your test references and use them. Okay? All right. But you've heard me say that before. Right? Okay. So we're looking for a sulfite ion, and a sulfite ion is SO3, 2 negative. It's an acid. What else goes on there? H plus. How many of those do I need? 2 of these. So I is going to equal 3. And I is going to equal 3 up here too, we said. Okay? Number 6. Potassium nitrate. Okay. Where do you find potassium?
You find it on
It's got to be in one of two places.
oxygen.
This one's on the periodic table. Where do you find the nitrate?
Probably it's on
What is its formula?
NO3.
Alright, so we have a polyatomic ion. This also has to be charged as well. I mean, you can't put a charged particle with one that's not. So what charge then are you going to put on this K? Oh, I'm sorry. Thank you. 1 plus. And where did you find that? Periodic table with oxidation numbers. Use the tools. Practice with them now. How many of each of those do I need? 1 of each. What is I going to be here? 2. I got 2 particles. I is 2. Well, I've got a 1 plus. And so the compound will have a 0 charge if I just have 1 K and 1 NO3. Okay? All right, number 7. Sc2 SO4 3. All right. What kind of compound is this going to be? Ionic. How do you know that? Well, the polyatomic ion is really the only clue you need. It's got a polyatomic ion, the compound has to be ionic. We need to know the charge on this. Well, actually, we probably don't need to know charge on this. All we need to know is how many particles we got. Can you figure it out? 2 here, 3 here, total of 5. Now, if that just doesn't quite, you don't quite grasp that idea, go back and look at the charges, break it up, and build a formula. Zach, stand up. Scandium has a 3 plus charge. Sulfate has a 2 negative charge. We've got 2 scandiums and 3 sulfates to make that formula. Okay? That's a total of 2 and 3 or I equals 5. Oh, is it? That's strange, huh? Okay. Yeah, I know it. All right. Well, let's look at this last one, number 8. Okay. CH3, you've got it on your sheet. You wrote it down, I hope. I don't know, because it's probably run out of space to save all this stuff. What kind of a compound is this going to be?
It's working now.
I know. What kind of compound is this going to be?